So here we have a theorem that hopefully makes good sense to you. Let's write this out symbolically. So we have two statements. F has a local max or min at x equals c. Okay, that implies that, oops, a couple mistakes here. It should be x equals c rather, x equals c here. And I forgot this condition, f prime of c exists. And f prime of c exists. Okay, exists meaning it's a real number. So if this is true, then that f prime of c must be 0. Okay, so in math, we have this statement implies that this is true. Okay, so hopefully this makes sense. If you have a function, let's say you have a max or you have a min, and the derivative exists at c. So let's say here we have c, and here we have c. So we're saying if you have a max or a min, so here we have a max, here we have a min, or local max rather, local min, then what must the derivative be at this max? Well, the derivative has got to be 0, right? You're going to have a flat tangent line there. And likewise down here. Okay, so hopefully that makes intuitive sense. But you got to be careful. You got to be careful because this arrow only goes one way. So let's write it like this. I'll put the arrow going the other way and I will cross it out because that is not true. So if f prime of c is 0, I cannot conclude that we have a local max or a local min. Let's see an example to illustrate that. F of x equals x cubed. If you look at f prime of x, you get 3x squared. If I set that equal to 0, I see that x equals 0 is a solution. So f prime of 0 is 0. But if you look at the graph of this cubic function, what's happening is you have a function that is, function that is rising, and then it flattens out momentarily right at the origin. So it gets flat right there, just for a moment, an instant actually, and then it continues on its way, like so. Okay, so right here we have f prime of 0 is 0, but there's no local max or min here. Okay, so just be careful. Okay, be careful, and just remember that these arrows do not go both ways. They only go from left to right.